Types of in-situ remediation for groundwater pollution prepared by Group 3. Introduction. What is groundwater pollution? Contamination of underwater sources due to industrial waste, landfills, and leaking tanks, etc. Why is remediation necessary? To protect drinking water, ecosystems, and public health. What is in situ remediation? Treatment done directly at site without removing soil or water. Advantages of in situ remediation. Minimal site disturbance, usually less costly than ex situ, can treat large areas over time, and reduces transportation of disposal risks.
Now that we have introduced the concept of in-situ remediation, let's take a look about the main techniques used in practice. Uh, these are five common types. The first is in-situ biodegradation. The second is in-situ chemical oxidation. The third is permeable reactive barriers or PRBs, surfactant enhanced remediation, and finally, electrical resistance heating, known as ERH. Each of these techniques are designed for specific contaminants and site conditions. Well, in situ degradation, this stimulates microorganisms to break down contaminants, also requires injections or oxygen or electron acceptors, and this is used for BTEX, TCE, MTBE, nitrates, and can be aerobic or anaerobic. Simple, low cost, but slow.
Now we are going to talk about the PRB, permeable reactive barriers. Uh, it's the groundwater flows naturally through the barrier, and then the reactive media neutralize and degrade or immobilize pollutants, and no needs for pumps or external energy. Here, it's a picture of of the PRB, and in the middle we have the reactive media. And this is in situ chemical oxidation. We have the injection of a strong oxidants, permanganate, Fenton's reagent, persulfate, rapid destruction of organic contaminants. The key challenges of this is that delivery and uniform distribution, the potential secondary reactions, uh, and most is used for VOCs, SVOCs, and fuels. And this is the picture of the in situ chemical oxidation.
Well, the case study by our team was the Elizabeth City project, located in the U.S. Coast Guard Support Center in Elizabeth City, North Carolina, which had primarily the contaminants were trichloroethylene, otherwise known as TCE, a chlorinated solvent. Then it was CRVL, a toxic heavy metal. And well, these contaminants formed a groundwater plume migrating toward the Pasquotank River. Well, the remediation approach used in this project, which was based on a permeable reactive barrier system, specifically a funnel and gate design. The funnel portion consists of impermeable barriers that guide the flow of contaminated groundwater toward the central treatment area. That leads us to the gate, which is filled with zero valent iron as the groundwater passes through this gate. The CVI reacts with the contaminants effectively, treating them in place. Well, now to the results and effectiveness of the system. Well, TCE concentrations were dramatically reduced from levels in the thousands of micrograms per liter down to values below EPA limits. Similarly, hexavalent chromium levels dropped below regulatory standards as well, which is, well, finally, like that. What's more impressive is that the system has been operating effectively for over a decade, with minimal maintenance required.
So now we can see the comparison between the techniques. First of all, the biodegradation for the speed is medium, but the cost is low. It is best for the PTX, the TCC, the MTBE, and the nitrates. And as a note, it's pretty simple and sustainable, but it's lower than other methods. The second method we're seeing it's chemical oxidation, which is a pretty fast method, and the cost is medium, and it's best known for the VOCs, best used for, sorry, VOCs, SOVC, and fuels. It's really fast and aggressive, but it needs really a lot of control, and you need people qualified to do this type of technique to be effective and do not damage the ecosystem. And that's the permeable reactive barriers that we saw on the case study. The speed is medium, but it's faster than the biodegradation. The cost is also medium. It's not as much as another techniques. And it's also used for DOC, but also metals. And it's passive, it's long-term effectiveness, as you saw, as my teammate Armando mentioned. This in the case study they use this, and it has been over a decade, and it's still functioning perfectly with so little maintenance. And as a conclusion, well, first of all, in-situ remediation is a practical and effective approach to a threat of underground contamination. The type of in-situ technique, it depends on three things mainly. The type of contaminant, site of condition, the condition of the site, and the cost and the time frame you need to clean up the water. Combining method is something the most effective strategy. Protecting groundwater is essential for public health and environment because it's one of the most abundant waters that we can drink in the world. Thank you.